yesterday or Monday, or you guys know what I'm talking about, okay? So we kind of had this picture, and you guys all took your paper plates, right? And we drew a radius. And you took that string and you cut that radius, right? We kind of have a picture of it right here. Okay? And what we did is we created an angle where this distance was exactly one radius, but it was that curved distance. So, and are we all in agreement that it doesn't matter the size of the circle, this angle will be the same no matter what?
Yep.
I don't know where she just stepped out for just a second. I'll tell her you're looking for her.
Yeah.
Okay? All right. And so we call that angle 1 radian. Now, how many of those angles fit around the circle? It was 6.28, yeah? Are you guys cool if I call it 2 pi radians? And why did that make sense?
Isn't 2 pi r? How do you get a radius?
2 pi r is the circumference. And what were we doing? So the biggest idea behind a radian, and I'm going to kind of give you the formal definition. It's the angle necessary. Did Mrs. Swery find you on the way back in?
Yes.
So that the arc equals the radius. And the biggest idea I need you guys to get here is that angle is essentially a rotation. So when you think about how we think about angles, like I always think about like in the Olympics, the snowboarders who do like a 360. They're talking about the same kind of degrees as an acute angle being less than 90 degrees. Okay, and what they're doing is they're spinning in the air. So angles are the same thing as spinning. Are we comfortable with that idea? Like, if my arm is starting out right here, and I do this angle thing with it, what's my arm doing to make angles? It's rotating, yes? Do you guys, everybody good? Does that make sense? I'm rotating my arm to make an angle. And if I wanted to, along with my wicked air guitar, I could rotate over and over and over again, yes? Okay. So angles equal rotation. All right, now. Here's why math nerds like myself love radians more than they like degrees, okay? The reason math nerds prefer radians, and it's not just math nerds, guys, it's also physics nerds sometimes and, science nerds. The reason we like radians is radians connect to length as much Now, here's what I mean by that. Rotations are used all the time in the modern world. Give me an example of something that uses rotation. Yeah. The wheels on a car. Hey guys, your car wheel spins, right? What's the result
Movement.
when your car wheel spins?
Movement.
What kind of movement?
Forward movement or
Forward or backward? If I were to say linear movement, like my car wheel spins, but what actually happens is I travel a distance, so the spinning is tied to the length I travel. Do you guys see what I'm saying here? And so when engineers and all that kind of stuff are doing these things, they prefer radians because radians are a lot easier to deal with length because is so that the arc equals the radius, like it's all together. That's why we care about radians. All right, now, we said 2 pi radians was all the way around a circle, yes? How many degrees does it take to get all the way around the circle? I'm sorry? So are you guys with me that the 2 pi radians, that's how many rotations, how many radiuses fit around a rotation, right? 2 pi radians equals 360 degrees. And so if I divide both of those by 2, I get that pi radians equals 180 degrees. We still good? Okay. So 360 degrees, 2 pi radians. And so what happens is we're going to set up kind of like this proportion every single time. All right. So if I asked you guys how many radians is 60 degrees, we're going to start with our initial pi over 180 equals. So equals, I'm going to call it x because we don't know how many radians, divided by the degrees, which would be 60. Now, when we do this, we typically leave radian measurements in terms of pi. So I look at this, I say x over 60 makes me want to times both sides by 60. Is everybody comfortable with that idea? And on that right-hand side, that 60 is going to cancel out. So now, when I say leave things in terms of pi, really what we have is 60 pi over 180 is equal to x. I'm going to let you guys look at that for a second because that was a big step. And this is when we say leave things in terms of pi. We don't actually press the pi button on our calculator. We just let it go. And then what we say is, can I simplify 60 over 180 at all?
Yeah.
Does 60 over 180 simplify?
1/3.
1 over third. 1 over 3. So we can say that 60 degrees is equal to pi over 3, 1/3 radians. Okay? 60 degrees is the same angle as pi over 3 radians. Guys, pi over 3. Are you guys comfortable with me saying pi over 3 is going to be a little bit bigger than 3? 60 degrees, pi over 3. 60. When yesterday Monday I had you guys calculate, like we did how many degrees is 1 radian. It was like 57.23. You guys remember that? 60 degrees is a little bit more than 1 radian. Pi over 6 is a little bit more than 1 radian. Those numbers make sense. Okay? Let's look at another one. So how would this change if I'm doing 96 degrees? We would say we're always going to start with pi over 180 equals x over 96. How do I get that x by itself? I'm under my breath. Multiply by the 96, and I get 96 pi over 180. Hey guys, how does 96 over 180 simplify? Do you guys know how to do this? Remember how to do that in your calculator? If you hit alpha y equals and bring up that fraction bar, and then just type in 96 over 180. You have to hit the alpha y equals so you get that horizontal fraction bar.
Yeah, 1.67.
No, the fraction, not the fraction.
Remember, we don't include the pi.
Yeah.
So let's see, 96 out of 180, I would assume is something like 8 pi over 15 maybe? Is that what it is? 8 over 15, so it'll be 8, since we didn't include that, we'll use that. Does anybody need help with the calculator on that? Jeff, are you good?
Yeah, I completely set that.
Yeah, I know. Do you need help getting that on the calculator? You good?
Yeah.
I got it.
Okay.
Kids never zone out, so
Alpha, y equals. So, we're just gonna put 96 over 90.
I don't know if I have
I reduced it, yeah. 8 over 15.
another one.
So it's 8 pi over 15.
All right, why don't you guys try 220? And if you're good with the 220, we won't keep rolling. Make sense?
This one's
Yeah.
you check this.
Did you get 11 pi over 9?
Yep.
So I was putting her thing 2.01. So,
Is that it?
yeah, that's it.
That's easy.
Challenge accepted.
Yeah, you're good.
Huh?
Bet I can make it worse.
No,
It's
no.
not even that bad, Jeffrey.
Do you want me to make it just a little? Can I make it just a little bit worse?
I like was waiting for the moment she said, I'm gonna make it just.
Yeah, I know. As soon as I said that's easy, I looked up. She said, challenge.
Thanks.
Okay, so a little bit worse?
I got this. I
Hmm?
already did it.
Wait, so are we basically just doing the opposite of what we just did?
Basically just doing the opposite. So we have pi over 180 equals 3 pi over 5 over x. And I'm going to let you guys look at that because remember, it's radians over degrees. That's what that fraction is. And so in my experience, kids flip out when they see this because it's a fraction within a fraction. And you guys don't like fractions.
So can't we just, never mind.
No, go.
It's not a complete thought.
Yes, Kale.
Can you do that for y equals twice on the calculator? Like that?
It would be great, except for
You don't know.
my x is in the bottom, which can make this kind of annoying. Okay? Now, you guys have heard the phrase cross multiply before, right? Okay. If I cross multiply, that means, and I can do that whenever the sign in between is an equal sign. It's pretty important that it's an equal sign. All right. So when I multiply across here, what is pi times x?
Pi x.
Pi x. That's it. Equals. Then I'm going to do 180 times 3 pi over 5. Now, does anything jump out at y'all?
The 108 pi.
You got 108 pi?
Yeah.
Okay, so then what you have then is pi. So you did 3/5 times 180 and then brought the pi along for the ride.
Yeah.
Cool. So I've got pi times x equals 108 pi. And Jeffrey got that 108 by doing 3/5 times 180. Yeah? Okay. All right, Jeffrey, keep going.
And then could you just divide by, well, I don't think,
Keep going.
the
Keep going.
pi-
Yeah, you're going to divide by the pi.
Yeah,
But guess what happens?
cancels out,
So how many degrees we got?
108.
That's it.
Jeffrey.
That's it.
It's not that bad.
Oh, that's pretty easy. Oh, no, I said it again.
I know. What's pretty hilarious is whenever you guys say that's pretty easy.
Yeah.
What do you guys think I'm gonna say next? Come on, we're at the point of the year that we can do this.
Okay, that's,
Once you guys try these two for me, make sure we're good with it. And then, I bet you know what's gonna happen next. Kale knows what I'm gonna say after that, right? Mrs. Jurig, I do teach, not today, but the unit circle significantly differently than Mr. Richards says.
Okay.
Just as a heads up, so if you want me to go over that with me 6th period before I teach it tomorrow, I'd be okay with that. Just so that you have a heads up of what it looks like. If you want. If not, no worries.
Yeah, I'm testing 6th period, so.
Okay.
But no, I'll just sit and I'll learn it the way you teach it when you're teaching them, and then I'll go. It's been so many years since I've had it with him that I forget, like, I feel like we didn't, yeah.
I have two, both of them don't, but I don't think they're right.
Did you get 140 for the second one?
140 for the first one.
That's what I said.
This is 9 going to 180.
When you say the first one,
You can cross this off.
the first of the new ones, but I looked at it and I was like, oh, the first one we did together was 108.
So I got 140 for that one and then 288.
288?
Yeah.
Did everybody get 288?
I got
Look at you.
way higher than that.
I mean,
I don't know how.
it would be.
Did you do 8/5
145, but then
times
you
180?
divide by pi, you divide by pi, so then x is 1.
Remember, we don't multiply with pi because the pi ends up canceling out.
Because you're trying to figure out what the degrees is, okay. So.
William, you good with this?
Yeah.
Kaylee, you good with this? What?
Yeah. Oh, you're.
Are you saying yeah or are you actually yeah?
Yeah.
All right, cool. All right, guys. Here we go.
I make you a bunch of that.
Oh, gosh, no.
You don't drink.
For which one? For this?
No, I got those. Probably these, like the bottom two.
I'll do that for you.
I have like 810.
A lot of people will, but it tastes good. So I got soda.
You ready? Ian, you want to know my response?
Yeah.
Please, I'll taste this soda.
Sure can.
That's the happiest I've ever.
I gotta have like a good air guitar song that I'm air guitaring with whenever I make that motion, right?
You should come up with a song for the
How many times
yes.
did I 180?
For
For
convocation?
the equation. No, the equation. If there's an equation.
No, guys, we're past the simple equations.
Pi over 180 equals radians.
All right.
I would say.
Uh-oh. How are you guys feeling right now?
Actually decent. I know it's not going to be okay.
Does it matter?
Yes, it matters.
Terrible.
I rarely ask you questions that don't matter. No, you guys might not agree on whether they matter or not, but they matter to me, right? I wouldn't ask a question. To come up with a good question is actually really challenging.
Oh, right. Definitely.
So I don't want to put forth that effort on things that don't matter. But you guys are feeling comfortable so far?
I mean, I know if I say yes, you're gonna be like, oh, okay, try this.
It's like
Oh, well, yeah, if you're feeling good so far, that means you're ready to move on. If you're not feeling good, you need to tell me so that we don't, move on before you're ready.
This is easy.
All right,
That's not
let's
a good
just
thing.
take a team for the bullet, or take a bullet for the team. Let's just go for it.
All right.
Let's just,
All right. We are going to start talking about angles in a way that is very, very different from how you have talked about angles in the past. Okay? Because we're not just going to talk about like angles in a triangle anymore. We're going to refer to them as rotations instead. Okay? And so now, here we have a XY coordinate plane. Yeah? Do you guys remember what these are called? What each of the four spaces is called, sorry. Quadrants. And which one is the first quadrant?
The one on the top right.
It's like a C.
This is quadrant 1. Quadrant 2 is the top left. Quadrant 3 is the bottom left. And finally, quadrant 4 is the, And we have kind of like this positive x-axis. And this is like the negative x-axis on this side. And up here we have the positive y-axis. Is any of this that I'm saying surprising? Okay. Now, what we haven't talked about is what does an angle, like everything we've done on the coordinate plane, we've like described slope, or we've graphed parabolas, or we've graphed lines, okay? We've talked about points. We haven't talked about rotation on the coordinate plane, okay? So the first thing I'm going to tell you is every angle has a starting side and a final side. And then instead of final, we call it like the initial side. And the initial side for any angle is the positive x-axis. In other words, that's 0 degrees. Okay? And to create any angle, to graph any angle on the coordinate plane, we rotate from here. And the reason we call this one the first quadrant is because that's where we rotate first. Is this okay? Okay, so let's go ahead and graph what 210 degrees would look like. 210. Okay? If I rotate to here, how far have I rotated? 90 degrees. And then to here, 180 total, right? And then, do I go all the way again? No. To get to 210, where do I need to go?
like half, or right there.
Roughly-ish here. Is this okay?
Yeah.
Okay, so I'm going to go ahead and draw that angle. This is what we call the terminal side. So far, is everybody comfortable with what I've got up there? So the first thing I'm going to expect you guys to do is be able to tell me where an angle is. Okay, is it in the third quadrant? Is it on the negative y-axis? Is it on the positive x-axis? Is it in the first quadrant? Does that feel like a reasonable thing? We just keep counting our 90-degree angles. Okay? All right. Now, for every angle we have something called a reference triangle. You guys are going to like the reference triangle. You want to know why? You just draw a triangle with the x-axis. All you do is you take that terminal side and draw a right angle to the x-axis, and it's always to the x-axis. What do you guys think? Is this still okay? We call that the reference triangle. Why do you look at me like that?
What about angles over 360 degrees?
Oh. I'm joking. I'm just waiting for her to say that.
I can just tell
Like-
her.
Like 570 degrees?
Yeah.
Guys, let's talk about 570 degrees real quick.
Ian.
Everybody, don't get mad at Ian. I was going to get there anyway, so don't get mad at him for asking an interesting question, okay? What angle did I say, 570?
Yeah.
570 would look like this. Let's see. 90, 180, 270, right? All the way around would be 360. And then I just keep going.
So like
450, 540. A nautilus, a little bit of a nautilus. And so I chose 570 kind of on purpose because I'm me. Yeah.
Oh,
Do you guys see how 570 and 210 end at the exact same place? That means 570 degrees and 210 degrees. Why I wrote 211? I don't know. Those are what we call coterminal. Why do you think coterminal?
360 degrees apart.
Because, well, co means with. In Latin, co, like your co-worker is someone you work with, right? Okay? These are two angles with the same terminal side. Okay? And it turns out that what's necessary for two angles to be coterminal? They need to be 360 degrees apart. How many angles are coterminal to 210 degrees?
That's a good question. It's gonna be infinite.
An infinite, yeah.
Because I can go around and around and around and around and around and around.
Another one.
And the seasons, they go round and round. Do you know that song? I bet you know that song.
Wait. Do it again.
And the painted ponies go up and down. We're captive on the carousel of time.
I said
Can't
we should
return, we
get
can
rid of this.
only look behind from where we came.
No.
And go round and round and round in the circle game. Joni Mitchell? No one?
I said
That
we
was
should
Joni
get
Mitchell,
rid
right? I'm pretty sure it was Joni Mitchell. See, do you guys miss Mrs. Roth yet? Because I promise I can make you miss her.
A little bit.
Okay.
I think you're better at explaining stuff though.
Yeah.
I will have been doing it a heck of a lot longer. Hey, what questions do we have so far?
No, don't do that.
Savina, please don't.
You're talking, you ask, you're like, this is easy.
All right. Why is it a reasonable question? I don't have a reasonable answer yet because we don't have enough of this yet. Okay. Reference triangle. Are we good with how we draw the reference triangle? So for example, if I drew this angle, the reference triangle would be right here. Yeah?
So should we draw that?
You don't have to. I'm just trying to make sure we're all good. Okay. What we always do is take that terminal side and draw a perpendicular line, and then the radius of the rotation becomes the hypotenuse of this right-hand triangle. Okay? All right. Not only do we have a reference triangle, we have a reference angle. The reference angle is always made here with the positive x-axis, or with the x-axis. It's the reference angle is always made up of the x-axis and the radius that got rotated around. Okay?
So the terminal side.
Mm-hmm. Is between the terminal side and the x-axis. So number one mistake kids make
What's that one mistake?
is they call the reference angle the one with the y-axis instead of the one with the x-axis. All right. So let's go ahead and graph each one of these angles and try to decide where are they. Guys, where is 235 degrees going to be? Let's see. We have 90. Tell me when to stop. 180. Where would the next one be? So let's see. This is 90, 180. If I go another 90, that would be at 270. So I don't want to go that far, right? Okay. So if I'm asking you for, so it's in the third quadrant. If I ask you what is this reference angle between that terminal side and the x-axis, what angle is that? How could we figure that out?
What's the middle of 180 and 270?
Is it the middle? Is it? How do I know it's exactly in the middle? Because that would say that 210 is also like halfway between.
Yeah, that's true. Ooh.
Are you with me? So to here, I did 180 degrees. And how many total degrees did I do?
180?
Nope.
235 total.
235 total. Yeah? So how could I figure out what this angle is?
180 minus 235 minus
In this case, I would do 235 minus 180.
which is 55 degrees.
That's so weird. I
Right?
was thinking that, but no, like, I was thinking that, but then I said something completely different.
You guys, this is something completely new to you guys. So you're going to second guess yourself to start. I'm okay with you second guessing yourself to start. I'm not okay with you second guessing yourself to finish. Cool?
Yeah.
What do you guys think so far? Is this okay? All right, so what if I try this one? Where's 140 degrees going to be? Which quadrant?
The second one.
Second one. Okay. Now, the reference angle here is still made with the x-axis. Okay, it's always made with the x-axis. Well, that's 180 degrees, right? So what goes inside?
50. 50 degrees. Why not? It's not at 180 yet. It's at 90. So I did 140 minus 90.
Degrees?
So the reference angle is this angle, right?
Oh, okay.
Do you remember that number one error that kids make?
Yep.
Because you're finishing 140.
Yeah,
So
so
wouldn't it be 40?
it's 40.
Okay.
It's 40. So here's the deal. You can't just be like, oh, I just subtract each time. Like you have to think it through, which is like, there's no set rule to follow. You have to think about where am I? Okay?
I'm surprised you got it.
I'm not.
Dubs.
Hold on. Where is 310 going to be?
Almost at 360. That's gonna still be at 180.
So it's going to stop here-ish, somewhere, right?
Yeah.
And the angle that we're talking about is this one.
So that'd be 360.
In this case, I would do,
It'd be 50.
it would be 50. In this case, I might do 360 minus 310.
Yeah, that's not terrible.
It's not.
But the next one's gonna be bad, I think.
I bet it's not as bad as you think.
Because it's.
Are we good that it's more than one time around?
Yeah.
So I've gone 360. How many more do I need to go?
One more.
60 more. 62 more. Wait. Yeah.
How did you get that?
Well, I just did 36. Well, isn't 365 technically? Or whatever. And then just 420, so I just added 60. Whatever. I don't really know. It's quick math in my head. I don't really pay attention.
So
Okay, Ian, can you help me out on like an operation that gets us there?
Yeah, 20 degrees. What? did 360 plus 90 and then minus 422.
Oh, yeah. So 360 plus 90 tells you that this is 450 degrees, and then you subtracted to get back to here instead of, so you got this angle instead of, guys, help me out. Can you guys do 422 minus the 360 we've already gone to figure out how much further we need to go? And the answer is, Jeffrey,
What?
62. So you were right.
I was right?
You just weren't describing it well. But you were doing it right.
Bet.
Okay? Is everybody with me how we got there? And Ian, what you did was, like, you essentially, the reference angle we care about is this one, which actually is that 62 degrees. What you found was that this one is 28.
Gotcha.
You with me now? Like, so to get to the 450 and then subtract, you subtracted from where the y-axis is
Yeah.
instead of, so you got to be a little bit careful about that. Yeah. See? This wasn't so bad so far.
I just feel like it's gonna take a turn for the worse.
Yeah. I mean, do you want something to always feel easy?
No. Because then you don't learn.
Now we're going to do things a little bit differently. We're going to plot a coordinate, okay? So if I were to plot the point 5, 12. Are you guys cool to be about here with this being 5, this being 12? And if the terminal side of an angle goes through that point, it kind of goes this way. Everybody good so far? All right. And if I draw in that reference triangle, all of a sudden, I have a right triangle. I know this distance would be 5. And this distance would be 12. And I can't remember if Mrs. Roth used this symbol. I'm going to use a fancy symbol for the angle. It's a 0 with a line through it. It's called theta. She did use it?
I think so.
Yep.
All right, now, could we figure out that last side of this triangle? How would we figure it out? We can use the Pythagorean theorem, yeah? So I would do 5 squared plus 12 squared equals, I'm going to call it r squared. Would that make sense? So it's 25 plus 144 equals r squared, and then 169 equals r squared. And we take the square root and get something. 13. All right. So our radius of our rotation is equal to 13. Everybody still good?
Yep.
Now, is it worth noting, no, it is worth noting, I'm telling you it's worth noting, that the 5 was the x-coordinate, the 12 was the y-coordinate, the 13 was the radius, and essentially what we did was x squared plus y squared equals r squared. Are we comfortable with that idea? And the reason I'm pointing this out is this might look kind of familiar from Mrs. Downer's class. Because that's the equation of a circle. And do we understand why the equation of a circle is related to angles? You ready? Right? Angles are just rotations. Everybody good?
Yeah.
Cool. So to find our radius, we can always do x squared plus y squared equals r squared. Okay, now, looking at this picture, guys, if I asked you, what is the sine of this angle, this one right here, what would you say? Because this is a right triangle, right? So we could just use SOHCAHTOA here.
So 12 over 13.
So it is what? 12 over 13. Now, here's what I want you guys to think about. What was that really? That was the y coordinate over the radius. So as we start thinking about sine on angles that are bigger than right triangles, okay, it really relates back to coordinates. The y coordinate, so the sine is whatever the y coordinate of an angle is over its radius. Okay? And this is where I start to diverge from Mr. Richards a lot.
Okay.
All right. Now, what's the cosine of this angle? 5 over 13. So hold on. How did we get that 5 and that 13? Really, what were they? They were x over r. And then the tangent is 12 over 5, which is really y over x. Oh, the 12 over 5 I meant to write here. And like for consistency reasons, I made that look a little awkward.
Did
Sorry.
you start recording again?
I did start recording again.
Okay, now I see
Doubting her.
it.
I mean, it's a reasonable thing to doubt. I'm pretty bad at remembering to record. I'm like the worst at it.
That's good.
Is this okay? Yeah. All right. So now what if I had an angle that's in a different quadrant? How do I find its sine and cosine and tangent? Okay, and it's going to change ever so slightly.
I'm sorry.
I don't blame you. I blame him. I can see what's going on here.
I keep my head going that way.
Guys, where's -3, 4? What quadrant?
Oh, it'd be the third quadrant. No,
The
no,
second.
second.
All right, so if I were to label what we have here, this is a 4, right? Now this is going to feel really weird. You ready? Guess what I'm going to label this? I'm going to label it -3. What does that negative tell me?
It's going, well,
It tells me I'm going in the x is going in this negative direction. So that negative is a direction thing, right? Is everybody with me? So like, I'm going to take 5 steps right now, guys. You ready? Should I do, if I go 5 steps this way, that's telling me I took 5 steps to my right, which might in my head be +5, but in your guys' head probably looks like -5, so we're going to call it -5. Okay? Or if I go back to where I started from, and I take 5 steps this way, how do we differentiate between 5 steps this way versus 5 steps that way? We might call this -5. And all that negative does is it tells me which side I went to. So it's not saying that the distance is negative, it's saying that the direction is negative. Is that okay?
yeah.
Because there is a difference between going 5 steps this way and 5 steps that way. They're not the same, I don't think. All right, so what's my hypotenuse? Yeah?
-25.
If we do x squared plus y squared equals r squared, our x squared, that -3, we're going to put in parentheses, plus 4 squared is going to equal r squared. We're just going to solve that. R is always going to end up being positive because the squaring of this is going to make it positive. So I've got 9 plus 16 equals r squared, 25 equals r squared, so my radius is 5.
I see what you're saying. Okay.
Now, so here's what we have. We have x equals -3. We have y equals 4, and we have r equals 5. So here's what I'm saying. If I go to do the sine of this angle, remember this is my angle. That's my reference angle, though technically this is the angle. Okay? My sine of that angle is going to be the y coordinate, which was? What was my y coordinate? 4 over 5. No big deal. My cosine is going to be negative 3 over 5. And now my cosine has a negative value. Because in that second quadrant, cosine's negative. Because the x-coordinate's negative. And so on and so forth. What's my tangent? Tangent is y over x, yes? So that's going to be 4 over negative 3, which I'm just going to put as an overall negative 4/3. See, this is easy. See, this is where it stops being easy, guys. This is not
I'm not
easy.
saying it's gonna be easy, so I know it doesn't get hard.
I mean,
It's still gonna be.
it's predetermined whether or not it gets more challenging. Your packet's already made, yeah? How are we feeling? Are we feeling okay? All right, so here's what happens. There's some basic like patterns that we can look at and get really, really good with, okay? In the first quadrant, x is positive, y is positive, r is positive. So since sine, cosine, and tangent are like different variations of these things in a fraction, if every single one of them is positive, then all 3 trig functions are positive. Now, what happens in the second quadrant? Like, what do I know about everything in this, on this side of the graph? The x is going to be negative. And in the second, so, all right, so I know x is going to equal a negative. What about y in the second quadrant? What about r? Positive. So any fraction with an x in it is going to be negative, yeah? So as I go back to these, only like this would be negative and this would be negative. Does that make sense? So in that second quadrant, only sine is positive. What goes on in the third quadrant? X is negative, y is negative, r is positive, yes? Will everything be negative?
No. Yes. Because honestly,
It's honestly, that's what I'm saying. Any square negative, it's multiplying a negative by itself, so that
so
But so we're not scoring anything here, right? In this particular case, sine would be y over r. Y over r, would that be negative? Because let's see. Sine is y over r. Yeah, that would be negative because we'd have a negative over a positive. Cosine is x over r. X over r. This over this. These two, positive or negative? X over r.
so it's just gonna be negative.
That would be negative.
Yeah.
Okay. What about tangent? Tangent is y over x. That would be a, y over x would be a negative and a, what's a negative over a negative? Positive. So in the third quadrant, only tangent is positive.
I'm assuming the fourth is cosine.
And then in the fourth, for similar reasons, only cosine is positive. So that can kind of help us. If I like know the sine and the cosine of an angle, I can tell you exactly where it's located, which quadrant. Is this still doing okay? No one wants to punch Miss Meister yet?
Not yet.
Challenge accepted. You won't do it.
Yeah,
Tell-
tell her challenge accepted.
Nah, I don't want it. You got it.
All right, guys. And angles. So we're gonna do a whole lot more here. Okay, you guys can handle this, right? I believe in you.
Definitely.
Hardcore, guys. Here's what I want you to do first. Just sketch me this angle that goes through the point -2, 5.
Okay.
So far, have we done anything crazy?
Nothing too bad.
Okay. Next step, you're probably going to need to find me that radius because I'm going to ask you for the sine, cosine, and tangent. Okay. How do I find that radius again? X squared plus y squared equals r squared, yeah?
Yeah.
Okay, so we'll have -2 squared plus 5 squared equals r squared. (29) Square root of 29. R equals the square root of 29. Cool.
Do we leave it like that, or do we?
I'm gonna leave it as the square root of 29.
Okay.
All right. So guys, what's the sine of my angle? Remember, sine is y over r, which in this case is
5 over square root, or wait,
keep going.
square root of 29.
5 over root 29.
Do we simplify, keep?
I'm fine with you leaving it just like that. Cosine? Yeah,
-2 over square root of 29.
-2 over root 29. Tangent? 5 over -2. See, this is easy. Does anybody feel like there's anything I've thrown at you that you can't handle?
Do you want the -2, because you really should?
I don't really care where it is.
Okay.
It's not going to really matter. You know what I would really hate, though? It's like -5 over -2. Like, if it was in that third quadrant, that would really bother me. A negative over a negative is a positive, and I expect you guys to know that for sure. Hey, next question. What is this angle? Lily, the look on your face just now was like a legitimate I hate Miss Meister look.
Hate is not the word
Can't
to
you just
describe
put
it.
in your calculator?
What do you mean just put it in your calculator?
We have sine and we have cosine.
I'd like you to pick the positive one, okay?
Yeah.
Hey guys, if I know that the sine of an angle is equal to 5 over square root 29, okay, so you're going to pick whichever one is positive, because those negative things can really mess that up. Couldn't you just take the sine inverse of that 5 over root 29? You guys with me? So you just hit second sine, and that'll tell you what the angle is?
68.2.
68.2 degrees, perfect. Now, guys, that told me this angle. But the next one I want you to find is the actual angle, which is from here to here. Because remember, it started at that positive x-axis and rotated up, yes?
So it'd be like 140. No, it's like 1 something, 15.
What operation do you want to do?
Well, I was mostly just guessing, like educated guessing, because I know I have the 90. Oh, so it'd be like 1.
You just do 180 minus that 68.2.
Yeah.
You got 111.8?
Yeah.
Yeah, so I was
I
close to
did it the other
115.
way. I did 90 minus 68.2.
Wait, what did you do?
I got a
I did
111.
90 minus 68.2.
To tell you what this angle was?
Yeah, and then added it to 90.
Got it. Yeah, that would do it. The same thing. Okay. That's the worst I'm going to make it today. Is that the worst I make it today?
Yes, please, yes.
I mean, we only got like 10 minutes left.
We have one more problem to try.
Maybe we should.
Let's do this one, then I'm going to let you guys try this one. And I'm going to kind of write the steps up in a little bit of time. How's my picture look so far, y'all?
Good.
Okay. How about my reference angle? Which means the angle I'm trying to find is this angle. After I get my reference angle, which is no. Talk to me.
You did it about 360.
I'm sorry?
You did it about 360.
In this case I did. Because when I look at, remember, I always start here and I go all the way around. I'm just short of getting to 360 degrees. And how short am I? I'm 11.31 degrees short of 360.
So just 360.
So it should be 11.31 below 360.
Okay.
So like there's no like, there's no several. To be like, oh, you add to 180 or you subtract from, it just kind of depends on where you are, what you're supposed to do. Isn't this fun?
This is weird. This is not very fun, but it's.
No, I will say this. It's not fun, but it's entertaining.
This is not entertaining.
I
I'm just
think
happy we have our teacher back.
I could do this for hours.
Why?
Now,
Oh,
there's one
more.
one more.
Hey, I say ending the page is a good day.
Yeah.
And you know what? It's weird. However many years you've been in this building, in this school, that's how many votes you get. So you get 1 vote, or 3 votes, or whatever. No, you get 1 vote.
I don't even get a full vote.
You know who gets a lot of votes?
What about,
I
Many
get,
would we all
so
together?
what about?
Yes.
the
Us combined, you didn't think of that.
I don't think combined. I don't think combined. You guys come up to me and Mrs. Uri. I hate to tell you.
Yeah, I think we need to do one more.
All right, guys. I want you to jump down on the next page to where it, because like if you look, this is more of the same. I'm not having you do more of the same, but there is one more style I might use to ask you these questions. And you know, I'm terrible and will ask you these questions, and I'm picking the harder of the two, so that you know what's going to happen, okay? So don't get mad at me. Get over it, okay? Is everybody with me?
I got over it 2 seconds.
All right. The tangent of an angle that is in the 3rd quadrant is equal to 4/3. Okay, so let's think that through for a second. Here's my angle, yes? It's always made with that x-axis. And if the tangent is 4/3, what do I know? I sort of know x and y. Don't I? Because tangent's y/x. So this is 4 and this is 3, yeah?
Yeah.
Except for, that's not actually true. What are the coordinates of this point, y'all? -3 and -4. Okay? What's r? We would do -3 squared plus -4 equals r squared. So you're going to end up with r equals 5. So now, what are the remaining functions? What is the sine of this angle? What is the sine, y'all? Sine is, yeah?
-3/5. Or is that -4/5?
Sine is -4/5. Y over x. What's cosine? -3/5. You guys with me? So I might give you different pieces of the I might give you the triangle in different ways, but you're still kind of bringing it back to draw the picture of the triangle to find your sine, cosine, and tangent. Fun. What's more fun than this?
Everything, to be honest.
Challenge accepted.
Taking history state test.
I'm not gonna lie.
It's really
It
not
is
bad
kind of
for
efficient.
GE.